Now I will give you one example about convolution sum. Arkadaşlar, this is my input signal, which is 1, 2, and 3 at 0, 1, and 2. And this is my x of n. And my h of n will be this, 1 over 2, 1 over 2 at 0 and 1. Okay, this is h of n. And these are the sample numbers, and these are the, let's say, voltage values or values. Okay, what am I what I am asked is to find, using this input, I want you to find the output y of n, okay, by using h of n. So I will use this notation very often. X is going to be the input to my system. This is my system. And then y will be the output, but the system is characterized by the impulse response. Okay, see, now I'm going to apply two things right now. One, I'm going to use the property that we had before. X of n will be written as the linear combination of Dirac n's, Dirac n plus 2 Dirac n minus 1 plus 3 Dirac n minus 2. And now I will use these to find out h of n arkadaşlar. So how can I write using h of n? How can I write y of n? Dirac n is the input, h of n is the output, plus 2 Dirac n minus 1 will give me 2 h n minus 1 plus 3 h n minus 2. Okay, so this is very easy. If you know the input, if you know the impulse response, you can easily write these properties, these outputs immediately. Okay, so now I am putting this over here, 1 over 2, 1 over 2, 2 times, like shift first, multiply by 2, this will be 1 over 2, 1 over 2 at 0 and 1, and at 1 and 2, it will be 1 and 1, and then it will be at 2 and 3, it will be like 3 over 2 and 3 over 2, 3 and 4. Okay, so am I correct here? No, not 3 and 4. This is 2 and 3. And finally, while finding y of n, what should I do? I would first look at zeros. I only have 1 over 2 at 0. Okay, 1 over 2. At 1, I have 1 over 2 plus 1, so 3 over 2. This will be 3 over 2 at 1. And at 2, 0, 1, and 3 over 2, which means 2.5, like 5 over 2 at 2. And at 3, I only have 3 over 2. Okay, so this is how I find y of n like that. Now I will explain one more way of doing the same thing arkadaşlar. Okay, this is much more important and much more useful for you to learn. Okay, this is like convolution sum that you will use more commonly than the previous case, because if I have a more complex input and more complex h of n, it will be very difficult to do all this like shifting, multiplying, and addition things a lot more difficult. Okay, so now I want you to focus on this part, and this is the main focus of this video actually. Now let me write the convolution sum formulation again. X of k times h of n minus k. Okay, So this is my output variable. These are my like summation variables, okay? Summation variables. So how do I start solving the question? I start solving the question by plotting my x of n. How was it? 1, 2, 3. 1, 2, and 3. This is like 0, 1, and 2. Now it won't be x of n anymore. It will be x of k. Okay? So h of n minus k. So now in the next step, I will draw 0 and 1 and 1 over 2 as my n to start, okay, h of n. Then I will change this into h of k. Now it is like h of k. Then I will take the reverse of this signal. Okay, arkadaşlar, reverse. Now it will be 1 over 2, 1 over 2. This will be 0 and minus 1. And now this is h of minus k. Now I will move like by n, okay? But this time, if you remember in this like h of n minus 2, what were we doing? If it is like minus 2, shift to the right, right? Shift to the right. But in this case, if it is like h of 1 minus k, I should shift to the left, okay? So it should be like if there is no shift, if it is like 0 as it is right now, if it is 1 minus k, then I should shift to the right, okay?